Okay, U5L3 we are on. So once again, these examples that we are going to get to are in the notes. This first stuff we're talking about, though, if you'd like to write it down, you can, is just kind of a general how we're going to attack these problems. So we have learned so far there are three different types of transformations. We have reflection, rotation, and translation. However, we can do a combination. We can translate and then we can rotate, or we can reflect and then we can translate, or we could do 10 different transformations. We're only going to be looking at doing 2 transformations on an object. So here's what this is going to end up looking like. For example, here we have AB. This is the original image. How we know what the second image is after I, for example, were to reflect it over the y-axis, just as an example. Remember that we call this new image A prime, B prime. That means a transformation has been done to it. It's our new image. So here's our y-axis. Again, this is just an example. You don't need to copy this down, just to follow along with. We know that with a reflection, we count to our mirror, count away from our mirror, count to our mirror, count away. So A is 1, 2, 3 points away from our mirror, the y-axis. So on the other side, I need to go 1, 2, 3. Here is A prime. Now we also have B, 1, 2, 3, 4, 5, 6, 7. I need to count away. 1, 2, 3, 4, 5, 6, 7. There is B prime. So here is after my first transformation. Holy crap. There we go. Now we can take A prime, B prime, and I can now do a transformation on that. So what we're going to call this new image after I do a translation on it, I'm going to call this a double prime, B double prime. That means we took our original image and we did 2 transformation. That's why there's 2 of those little dashes. So I'm going to translate it -1, -2. Now again, just refreshing our memory here. This is the negative x direction. This is the negative y direction. So this means left 1 and down 2, but we should know that. So each point I'm going to go left 1, down 2. This is now a double prime. I'm going to go left 1, down 2. This is now B double prime. So there is my next image. So you're not going to have to perform these transformations. You actually are just going to have to identify them. But I just wanted to show you that's how these happen. We're going to end up with 3 images, the original, the one after one transformation, and then the next one after the next transformation. Now, again, like I said, all we're going to have to identify is what happened first and what happened second. What we're going to do is focus on how we got from the original shape, I'm going to call it just A, to A prime. That's going to be our first answer. And then how we got from the prime shape to the double prime. So we're going to have 2 answers. How we got from the plain letters to the prime letters, and then from the prime to the double prime. Now the key here is to focus on the orientation of the points. Okay. The key here is to focus on the orientation of the points in order to get the right answer. Because, for example, when we have a translation, if I got my calculator here, whenever I translate it, notice its orientation stays the same. It stays facing up. Even if I slide it diagonally, it's still facing up. I'm not turning it like a rotation, and I'm not flipping it. So if the orientation of the points stay the same, it's facing the same way, that's guaranteed to be a translation. If it flips or rotates, we're going to have to think a little bit more carefully about how to identify that. So let's look at example 1. This is in your packet. So our first answer here is how we got from triangle DFG to triangle D prime, F prime, G prime. So for your first answer, we need to ignore the double primes. In this case, it's green. In your packet, you don't have color. We are focusing on the black triangle and the red triangle. So we're going to kind of do process of elimination here. It's either rotation, reflection, or translation. So the first thing we ask ourselves is, are the points oriented the same way? Notice it goes F, D, G. Here it goes F, D, G. Those are oriented the same way. That's what we mean by saying orientation. F is on top, then D is to the left, F is on top, then D is to the left, and G is below. So this is guaranteed to be a translation if the points stay in the same orientation. Let's try the next one. I'm going to kind of help you guide through this the first time, and then we'll try it on our own. So now we are looking at the single primes to the double primes. So now we need to ignore the top shape. We're looking at red to green. Are these points oriented the same way? It goes F, G, D, D, wait. Are those oriented the same way? No, it's not. F is up here in this corner, and now F is over here. That can't be a translation. It has to be a reflection or a rotation. So let's see, is this a reflection? Well, no, it can't be a reflection either, because if it was a reflection, point F and point F would be right next to each other. If I reflect something, I need to have the reflection on the other side. And that's not a reflection. Yeah, D reflecting onto F, that makes no sense. This has to be a rotation. However, you are going to have to, if it's a rotation or reflection, you do have to say what kind. And here's how you can tell. Let's look at G. G goes all the way up to here. We need to say if it's a 90, a 180, or a 270. And here's how we know. Each quadrant, and you may want to write this down, is worth 90 degrees. Each square is worth 90 degrees. That should make sense because that makes, hey, look, 90 degrees. So notice that G travels through 2 quadrants to get to this point. It goes through this one, it goes through this one. So this is 2 90-degree rotations. That means this is a 180-degree rotation. Now, the last thing you have to say is it clockwise or counterclockwise? If you need to, draw a little clock. Clockwise goes this way. 1, 2, 3, 4, 5, 6, 7. Draw a little clock on your paper. Yeah, that's, whoops, 12. 12 is in there. So this is clockwise. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Counterclockwise is the other way. So looking at the direction we rotated this way. Here is clockwise. Are those the same direction? Yes, they are. This is clockwise. Clockwise follows the direction of a clock. If you need to draw a little clock for yourself with an actual clock face, draw it. Figure out which way is clockwise, which way is counter. This follows the direction a clock increases. And there we go. There's my 2 answers. Translation and 180 clockwise rotation. Now, again, it doesn't matter that it's clockwise necessarily actually here because it's 180 degrees. A clockwise or counterclockwise 180 degrees is going to be the same, but we want to practice identifying if it was clockwise or counter. Let's try it again. It's going to go a bit faster here now. So once again, we are looking the first time, we are looking at D, F, G to D prime, F prime, G prime. We are ignoring the double prime for our first answer. So let's go through the motions. We check for translation first. I'm looking here and here. Are my points oriented the same way? Nope, this cannot be a translation. F is up here and F is down here. Can't be a translation if the points switch places. Now we need to see if it's a reflection. If it's a reflection, that means that I could flip D down. Oh, I can't do that. I can't flip D down here. I can't flip F down here. This can't be a reflection. Therefore, it has to be a rotation. We need to determine how much it had to rotate to get there. So I'm going to erase this so we can see. when you are determining the rotation, you only have to focus on one point. You need to ask yourself how many quadrants it traveled through, not including the one it started in. So be very careful here. Let's focus on G, why not? You could focus on F, you could focus on D, it's gonna be the same thing. Not including the one it started in. G travels through 1, 2 quadrants. So to get from here to here, it travels through this quadrant and into the next one. So again, this is 1, this is 2, that's 2 90s. So this is once again 180-degree rotation. Don't count the quadrant it starts in. It travels through 1, it travels through 2, that's 180 degrees. Now again, I want you to say, is this clockwise or counterclockwise? Here's our clock. We got 12, 1, 2, 3, 4, 5, 6. We can keep going, but this is clockwise. The other direction is counter. So looking at our directions here, is G traveling clockwise or counterclockwise? Clockwise as well. Notice we rotated this way. A clock goes this way. This is also a clockwise rotation. Okay, so there is our first one. Now we need to look at our second. So now, okay, so now we are looking at the single prime to the double prime. So D prime, F prime, G prime to the double. D double, F double, G double. So I am now focusing on these two. Now you have to focus. We are ignoring the black shape. I want to know how I got from here to here. So we go down the list. Are the points oriented the same way? Yes, actually. G is up top, G is up top, D is off to the right, D is off to the right, F is down below, F is down below. So since the points are oriented the same way, what is this? A translation, reflection, or rotation? This is a translation. If I just slid it over, if the points stay in the same order, this is a translation. Again, it's a translation, you don't have to say how it's oriented.
Hi, this is Dr. You're reading on my lap. Sure. Sorry. No problem. Thanks so much. Oh, have it.
I keep getting interrupted. I have to keep cutting the video. Okay, last example here. So I'm going to guide you less through this. I want you to try it completely, pretty much on your own. We are looking at triangle DFG to triangle D prime, F prime, G prime. We're looking at, actually I'm going to let you try it. Find those two shapes. Go through the list. What do you think happened? If the points stay in the same order, that's a translation. If the points mirror each other, that's a reflection. And if the points do not mirror each other, but don't stay oriented the same way, that is a rotation. Major, what are you doing? Thank you. So what do we think for this first one? We're looking at these two shapes up here. F to F prime, D to D prime, G to G prime. What does that look like? This is a reflection. Now you do need to say when it's a reflection, what it is over. So what is our mirror here? This right here, if you notice, this is now a reflection. We haven't seen an example of this yet in this lesson, but I am flipping over this line. That's why this isn't a rotation here, because they do mirror each other. F mirrors F prime. G prime mirrors G, so forth and so on. So this is what it's flipping over. What is that? That is the y-axis. So we do need to say if it's a rotation or a reflection, we do have to say what kind. Now we're doing D prime, F prime, G prime to the double. Oh, for Pete's sake, come on. There we go. Triangle D, double prime, F, double prime, G, double prime. So be careful here. We are looking at the red shape to the green shape. Ask yourself, are the points oriented the same way? That's a translation. Do the points mirror each other? That's a reflection. And if not, that means it's a rotation and we got to figure out which. So what do we think here? This is a reflection. If you notice, G prime and G double prime are mirroring each other. D double prime and D single prime are mirroring each other, and F as well. F, bloom, flips all the way over down here. Now if we notice, they are mirroring each other over this line. F flips all the way down here, G flips here, D flips here. So what is this now a reflection over? What do we call this line? The x-axis. So there are my two answers. Reflection over the y and reflection over the x. Major, shush, give me a sec. So you're going to practice this a couple more times. It gets easier the more you practice it, but just keep in mind those things. If we are oriented the same way, that's a translation. If the points mirror each other, that's reflections, just like in this one. And if neither of those things apply, that's a rotation. We need to count how many quadrants it travels through. It's that many 90 degrees. So just real quickly, just one example here. If I have a point up here and it ends up down here, be careful with your options. This could be two different types of rotations. I'm going to actually move this over. This is going to be a rotation, but it could be this rotation or it could be this rotation. Here, it only travels through one quadrant. Here, it travels through 1, 2, and 3. So you have to be careful. This is a 90-degree clockwise. This is 90 plus 90 plus 90. That's 270 degrees counterclockwise. Look at your options on your assignment. It's possible that you're not wrong, but with the options they give you, you have to pick one. Every rotation could actually technically be two. I could rotate this way or I could rotate the other way. So be careful on your assignment. Look at your options.